This video will review zonal statistics and zonal statistics as a table. Zonal statistics, found conveniently under the zonal toolbar, can really be thought of as the spatial joins of the raster world, where they allow you to take some zone or some grouping, right? So maybe the grouping is just all farms. Maybe the grouping is every single farm individually. Maybe the grouping is a vector layer here, like municipalities in Lancaster. Regardless of what it is, those zones, those boundaries, those discrete contiguous areas are calculating some statistic. Huh. That's interesting. Just give that a second. Sorry about that. Right? Any of them is going to be calculating a statistic based on some raster grid, right? So I have a grid cell or grid layer of elevation here. So maybe I'm going to have every single farm, right? Tell me what's the average elevation for that farm, or what's the rate of change, the range of elevation, or what's the max elevation. Same thing, maybe I'll have each municipality tell me, right, what's the range of the elevation, or what's the minimum or maximum elevation. Right, so the first thing, zonal statistics as a table. So I open zonal statistics as a table. What comes first is always the zone, right? Notice raster or feature, right? So I could input a region grouped farms, right? Every single individual farm. Or what I want to do, muni, right? Muni, municipality, right? I take a look at where the values are. These are the values that I want. So the zone field is municipality. Essentially, zone field is what's the field, right, or the value, if it's raster, that's causing these to be considered discrete, right? In this instance, I'm saying you're discrete based on what your name is. If you're Adamstown Borough, you should be different than Akron Borough, so that's what that does. Value raster is, what's the raster I'm using to calculate statistics? We want to do some statistics for elevation. I want to say municipal zonal. Zonal stat. Statistics type, with zonal statistics as the table, I can choose from many, right? The average, the maximum, the minimum, the range, the standard deviation, the sum. Right? One thing that we'll notice here, rather I'll show an example of this in a second, right? But let's just calculate all statistics here. Hit OK. Right, I get a nice table for every single municipality. Right, those are the zones, and they tell me, look at that, what the maximum elevation in each is, the range, the mean, the standard deviation. And because this is a table, I can take it and I can join it right back. Right, so join it to that. It was municipal, it was municipal. And now every single region can tell me all of its information area. Right, that's pretty neat. And so maybe one thing I want to show is the range, right? Show me which ones have the greatest rate of change. So I'll go to quantities, pick range, right? Set a quantile. And now I can actually look. And lo and behold, if I jump back and forth, those do tend to be the ones that are in kind of hilly areas where they rapidly change, right? From kind of hills to not, where these tend to be areas that don't see a lot of grade change. I'm going to remove the join, right, and I'm going to bring in landcov_fin, something that we've been using in class occasionally. Right, and landcov_fin, if you remember, really all it is it's a layer saying a value 1 through 5 for whether you're urban, agricultural, forest, wood, or other. Right, these are meaningless values, and the fact that 2 is not greater than 1 and 3 is not greater than 2, they're used to almost categorically classify whether something's urban, agriculture, or forest. When I used elevation, the numbers actually mattered, right? Like 10 is 2 times as much as 5, and 20 is 2 times as much as 10. So whenever you want to calculate some statistic here, do zonal statistics as a table, bring in landcov_fin, right? Because the numbers are integers now, and they're not float like they were here, it opens up new ones we haven't seen yet. primarily majority, median, minority, and variety. Right? Majority, which value happens most, right? So if I clicked majority, it would tell me for each municipality which land use type is occurring the most, right? Are there the most cells with the value 1, 2, 3, 4, 5? Same thing with minority. What's happening least? Median, you know what a median is. It looks at them all and looks for the kind of median value. That wouldn't necessarily be helpful to us here because 1, 2, 3, 4, 5, they're not kind of numeric values. Or rather, they're not linear values. And finally, variety, right? Variety would give me an answer between 1 and 5, and what that would mean is there's one right type of land use in me, or 2 types of land use, or 3, or 4, or 5. We'll do majority because it's the easiest to understand. Right, and then we open it up. Very cool. You can see a lot of urban, a lot of farmland, and some that happen to be forest. Nobody has wood or other as their major use. I could join this back to the municipality. Before I do that, let's just change these values. Right? Urban, be a little gray. Agricultural, be a light yellow. Forest and shrub, be a dark green. Woodland and wetland, be a blue. Other, be black. All right, so I'm going to join what I just created. Majority, sorry. Right, municipality was the zone for each. And now each municipality is telling me, right, the land use type that happens most, right? 1, if you remember, means urban, 2 means agricultural, 3 means forest. Right, so let me symbolize them in such a way that I can see for each. Does it have more urban land? Does it have more farmland? Or does it have more forest land? Right, so I'll take municipality. Symbology, go to categories, right? And I know that means urban is most, agricultural is most, forest is most. Try to give them colors that are similar, right, to what we've seen before. The grays, the yellows, the greens. And look at that. I can jump back and forth and I can see I'm pretty accurate, right? Those municipalities that tend to overlap the largely urban areas tend to have most of their land urban. A lot of areas tend to be farm, but there are several areas here, here, and here, which tend to have a majority of the land cover in their area as forest. Right, so we've seen its use as a table and joining it back to a vector or raster. But you can also use it as a raster, right? So what I'm going to take here as my zones is the region group that I did a couple steps ago. A totally arbitrary value, all that it means is I am a discrete contiguous farm block. Cool, just an object ID sort of. So I'm going to say for those region grouped farms, right, the value is what differentiates them and makes them discrete. I want to calculate some statistic about elevation. We'll just do range because it's easiest. Farm stat range. Hit OK. Right? What returns is a raster. And look at that. It's values that essentially mean the range of elevations. Right? So I could symbolize them in such a way that they're going from low to high here. And all those areas that have a high, right, range of elevation change, if I look at where they were, look at that, they're lying right on elevation where there does appear to be. Whereas these ones appear to be in areas that doesn't have a huge elevation change. Right, so the difference between the two is when I use zonal statistics, my output is a raster, and the values are whatever statistic you calculated about this grid layer, right? So I had farms. Their kind of value that determined are they a discrete farm, that's what treated them as zones. They calculated some statistic about raster, elevation, sorry, they calculated some statistic about elevation, which was the range in elevation, and they returned with values that meant range in elevation, right? So I could go to that. The range in elevation here is 137, 205, 109, 234, 94, 181, 278, and so on.